Our next form for estimating an integral is called Simpson's rule. Thomas Simpson in the 1700s in England taught himself mathematics at home, as I'm sure I did and all of you did as well. At 15 years old, he was a schoolmaster and he was a math professor. 15 years old, taught himself math. Very impressive. Simpson's rule, named after him. Johannes Kepler did use a similar method 100 years or so earlier, so you might hear something like this referred to as Kepler's rule as well. And it's equivalent to something called the 3-point Newton-Cotes quadratic rule, which you can forget about for now, but we will cover in the fairly near future. Well, let's take a look basically at how the model works. The basic model says you're going to take 3 points. A is the left point, B is the right point, and then M is the midpoint. A plus B divided by 2. So we've got 3 points, even, in other words, 2 sections that are equal width. We're going to use the method of undetermined coefficients. You don't need to remember that term, but we're going to use it in the next video. We'll use the method of undetermined coefficients to find a unique quadratic that passes through the 3 points, A, f of A, midpoint M, f of M, and then the right point B, comma, f of B. The area under the quadratic is going to be our estimate of the integral from A to B. So here's how we end up estimating it. Our area of f of x from A to B under the curve is approximately equal to the width of the interval, b minus a, times alpha times f of a, beta times f of m, plus gamma times f of c. Remember, a, b, and c are equal spaced points on the x-axis. M is the midpoint. So our job is to figure out alpha, beta, and gamma, or maybe that was Simpson's job to figure that out. So alpha, beta, and gamma are chosen so that the estimate is exact for quadratic polynomials. So the estimate will not be an estimate for quadratics, it will be exact. And as a note, I said that one Simpson's rule instead of 2 trapezoids. Remember, if you have A to B and take the midpoint, we would add the area of the 2 trapezoids in the trapezoidal rule. Well, instead, we're just doing what's called Simpson's rule, with A, f of A, M, f of M, and B, f of B.